The following presentation will give you insights on an in-depth analysis on regression analysis. In this presentation, you will hear from myself, Chris Lowe, Jesus Gutierrez, Sean Moore, and Icy Cockerham on a set of data we have been working on and how we can analyze that data shown. A regression analysis is a powerful statistical method that allows you to examine the relationship between two or more variables of interest. Regression analysis is important because it allows you to confidently determine which factors matter most, which factors can be ignored, and how these factors influence each other. Let's discuss why we took out some of the grades. We get rid of some of the grades because they are completely irrelevant to our data. The purpose of performing regression analysis on this set of data is to predict how many or which specific independent variables are going to have an effect on the final grade. Therefore, we want to choose data based on what a student with intentions of passing can accomplish. This data is the data we were given before running a correlation analysis or a regression analysis. Now, if we scroll all the way to the bottom, we can see about 4 rows that are full of zeros. Now, this may be a situation of a student that dropped the class or students that just don't apply themselves fully. So therefore, we know it would not be a good representation of the students applying themselves, so we don't want to find this relevant to our data at all. Instead, we used only the data of students that took exam 1 because it indicates they made an effort to try and pass the class.
We conducted a correlation analysis to determine what assignments were highly correlated to total points earned. That ended up being exam 2, exam 3, chapter 10 exercises, the pre-lecture for chapter 11, and exam 4. And exam 2 and exam 3 were highly correlated with each other, and exam 3 was highly correlated with chapter 10, chapter 11, and exam 4. And chapter 10 was highly correlated with chapter 11. Due to this, we had to eliminate some variables, and that ended up being exam 3 and the chapter 10 to get the variables we needed for the regression. And so we kept exam 2, exam 4, and the pre-lecture for chapter 11.
Now that we've ran the regression analysis, we can analyze what this information means. The R-squared value explains how much of the dependent variable is explained by the independent variables that we chose. This number we have right here usually comes in a decimal form, but I've already converted it to a percentage to better understand how much of our data is explained by our independent variables. In our data, we can see that this is 93%, which is great because that means that our independent variables we chose greatly explain our dependent variable. So in this case, the tests and assignments we chose, these right here, are good indicators of what a student can expect as a grade based solely on these scores. Now moving on to our ANOVA table, the most important variable in this whole table is this number right here, which is our significance of F. Now, why is this important, you may ask? The significance of F lets you know if your equation is appropriate and usable for what you're trying to do. As you can see in this cell right here, our number is lower than 0.05, which is perfect. And to make sure that we did things right, we can also take a look at our p-values, which are basically how accurate and how usable our independent variables are. And luckily, those are less than 0.05. And now that we understand what all these tables and numbers mean, and we verify that these numbers are usable, we can go ahead and plug them into our equation to help students have a better idea of what they can expect in this accounting course.
So now that we have all this data combined together, we're actually able to determine what a student might score in the class just based off of these 3 independent variables. So with our exam number 2, let's say the student scored a 90 out of 100. And then let's say with the chapter 11 assignment, they actually scored a 20 out of 23. And these are being multiplied by our coefficients that we see here. And then for our third variable, our exam 4, let's say they scored an 85 out of 100. That would come out to an estimate of a 91% in the overall class. And this isn't saying that they only would have to do these 3 assignments to actually get the 91. This is saying that based off of their history and based off the typical patterns, if a student is at that point of an exam 4, if they're scoring at 85 on their exam, you have to look at all the assignments before that. They're also probably scoring higher on those, and that's what this data tells us. Not that these are the only 3 assignments that they would have to do, which helps us really get a much better idea of what assignments have the most impact in the class.
In conclusion, you can plug in any score to the corresponding test in the equation and get a prediction for what your final grade in the class will be. It's just a prediction, but if you did well on exam 2, exam 4, and chapter 11 lecture, you probably did well on earlier assignments, which would explain a higher success prediction for the class.